We've all been trapped in the digital purgatory of a modern app failure. You tap a button, and instead of getting an error message, you just get a frozen, spinning loading wheel that spins forever. 10 years ago, software used to break loudly. It would crash to the desktop or give you a stark error code. Today, the apps we use live across dozens of different servers. When things break, they don't crash. They hang in silence. This happens because of a beginner's trap called the happy path. It's an architectural mindset where developers build systems asking, what if everything works perfectly? They write code that blindly sends requests out across the internet, expecting a fast, clean response every single time. Trusting the internet to be perfectly reliable is like trusting that notoriously flaky group project teammate who ghosts you right after the kickoff meeting. You're handing off a critical task and just hoping they deliver on time. In a distributed system, assuming network reliability is a fundamental architectural flaw, one that guarantees a total system collapse. Modern applications operate as vast networks where hundreds of independent services, databases, payment gateways, and external APIs must constantly talk to each other. Across those connections, failures happen constantly. A server gets overloaded, a router drops a connection, or an API just takes 3 seconds longer to respond than usual. The true threat to stability is the wait. Every second your main application pauses for a struggling notification service to reply, it holds open the connection. Memory and internal requests start piling up behind it. That single minor delay stacks. The system waits, resources run out, and the bottleneck ripples outward to healthy components. Suddenly, a tiny delay in an email service exhausts your server capacity, and your entire application collapses under its own weight. Large-scale platforms like Netflix experience these identical network failures thousands of times a day, yet you almost never see their platform go offline. They stay online because they know a system is only as strong as its weakest dependency. To survive at scale, you have to draw strict boundaries around your external services and actively control how you interact with them. To stop cascading failures, give every external request a strict timeout deadline. If it doesn't respond in 2 seconds, the request is destroyed. But don't freeze the app. Use a fallback to instantly route the user down a secondary path, moving them forward. In distributed systems, delivering a partial, degraded experience, like a dashboard without the latest analytics, is always vastly superior to giving a user a frozen screen. When a request fails, developers instantly retry it. But if thousands retry simultaneously, they create a retry storm, hammering the server offline. Fix this with exponential backoff. Increase the wait time. Retry after 1 second, then 2, then 4. This gives the service breathing room. Before you enable retries, you must guarantee operational safety through a concept called idempotency. An operation is idempotent if executing it multiple times produces the exact same result as executing it once. Imagine a user clicking a checkout button. The request hits the payment gateway, the payment processes, but the network drops the confirmation. If your system blindly retries that non-idempotent request, you will charge that user's credit card a second or third time. Retries act as a weapon that can destroy your database. Without mathematical safety, repeating an operation risks corrupting your records and double charging your users. You have to stop designing software for those rare, fleeting moments when the internet works perfectly. Instead, assume the network is chaotic and hostile. Before you integrate any new service, run through the survival checklist. Ask yourself, what happens when this call fails? Do I have a strict timeout in place? And if I have to retry, is the operation idempotent? Network resilience provides the foundation for the next challenge, eventual consistency. This is the reality of dealing with a world where different servers show users different data at the exact same moment. Amateurs build systems and hope they stay up,